Welcome to This Explainer, everyone. I am absolutely thrilled you're tuning in today because we're putting on our detective hats. We're going to open up the case file on one of history's absolute greatest scientific mysteries. It's an event that sounds straight out of a science fiction movie, but it was incredibly, terrifyingly real. We're going to look at the evidence, analyze the data, and piece together exactly what happened during what is now known as the Tunguska firefall. So if you love a good mystery and you're ready to think like a scientist, you are in the perfect place. Let's get started.
So here's a question for you. How exactly do scientists solve a mystery when the physical culprit has completely, literally vanished? In most investigations, you have some sort of physical evidence to go on, right? A rock, a chemical signature, maybe a piece of debris. But what do you do when a massively destructive force leaves behind absolute devastation and then just disappears without a trace? That's the exact puzzle researchers faced with this case. Let's flip open our case file and travel back to the very beginning to see what they were dealing with.
I really want you to picture this. The year is 1908. Dawn is just breaking over a super remote, incredibly dark forest in Siberia. You've got this thick, cold fog just hugging the bases of these towering ancient trees. It's dead quiet. It's incredibly peaceful. The air is completely still. Honestly, there is absolutely zero warning of the cinematic, earth-shattering chaos that is about to hit this isolated landscape.
Okay, let's break down the timeline here, because the sheer speed of this event is mind-blowing. That eerie morning silence, gone in an instant. Just moments later, a fast-moving, intensely glowing object absolutely rips across the sky, leaving a massive fiery trail right behind it. Seconds later, a blinding flash of light shocks villagers miles away who are looking up in total confusion. And then, boom! Instantly after that flash, a massive shockwave hits. In a matter of seconds, the forest is violently flattened. Birds are scattering in total panic, animals are fleeing, and towering trees are literally tossed into the air like they're matchsticks. It was basically the slow-motion destruction of an entire landscape.
Section 1. Clues in the Forest. Gathering the case file evidence.
All right, let's dive into this and transition from what happened to the clues left behind. The event itself was over in moments, but the scars on the Earth, scientists would study those for decades. When researchers finally made it out there years later to explore and take notes, they found a really bizarre scene. First off, looking at the distant villages, the shockwave was so powerful it shattered windows miles and miles away from the epicenter. Second, the landscape itself was just totally scorched, with lingering smoke and an eerie silence where a vibrant ecosystem used to be. But the third clue, down on the forest floor, is the most crucial. An endless sea of fallen trees, all laid out in this perfect radial pattern pointing outward from a central spot. It was a massive footprint of destruction.
But out of all those crazy clues, the scientists studying the damaged ground found something even more shocking. Zero. Nothing. Despite a blast powerful enough to flatten an entire forest into a perfect circle and blow out windows miles away, they found absolutely zero impact craters, not a single one. Just a completely flat, burned center.
Which brings us to the million-dollar question that baffled early researchers. If a massive object slammed into the Earth with that kind of crazy force, where on Earth is the crater? It really forces you to think critically, doesn't it? The scientists literally had to go back to the drawing board. They were poring over old maps, digging through historical documents, analyzing those blinding light descriptions from the villagers, all trying to figure out how an impact this huge just leaves no hole in the ground.
Section 2. The meteor entry theory. Simulating the unseen culprit.
Now, what's really interesting about this slide is how the missing crater forced a huge shift in scientific thinking, moving us right into the hypothesis phase. If the ground wasn't hit, what actually caused all that damage? Let's walk through the chronological steps of the modern scientific consensus. Step 1. A massive meteor enters Earth's atmosphere at an absolutely extreme speed. The friction is off the charts. That leads directly into Step 2. The object glows intensely from the extreme heat, the pressure builds up, and it violently breaks apart. Which triggers Step 3. Instead of smashing into the dirt, all of that kinetic energy is released in a massive midair explosion. So that bright flash the villagers saw, that wasn't an impact. It was the meteor basically dying in the atmosphere.
To really wrap our heads around this, we need to add a crucial term to our scientific vocab, an airburst. This is a super powerful explosion that happens mid-air rather than hitting the ground, which creates a massive downward shockwave. This single physical mechanism is the absolute key to our entire case file. Because the explosion happened up in the sky, it pushed a literal wall of air straight down. When that air hit the ground, it blasted outwards in all directions. And boom! That perfectly explains our missing crater puzzle, and it beautifully explains why millions of trees were flattened in that exact outward-pointing pattern.
Section 3. Measuring the massive impact, the scale of destruction. And this brilliantly illustrates the sheer scale of the event we're dealing with. Getting the right scientific theory makes all that confusing evidence just snap into perfect alignment, doesn't it? But understanding the how is really only half the story. When modern scientists run simulations of the massive energy released during the Tunguska airburst, the only thing we can really compare it to is a modern nuclear blast. The sheer power was utterly dramatic. The intense heat, the blinding light, the raw force that just snapped ancient trees like they were twigs, we're talking about energy equivalent to a multi-megaton nuclear detonation. It's a deeply humbling, awe-inspiring reminder of the terrifying amount of energy that nature and our cosmos can unleash in just a fraction of a second.
But nature has a way of moving on. Just hours after that apocalyptic level of destruction, the dust actually began to settle, the smoke started to clear, and the terrified villagers, along with the completely ruined forest, sat beneath this calm after the chaos, a peaceful night sky just absolutely filled with stars. A deeply mysterious tone fell over Siberia. It was like the universe had violently reached out, touched the earth, and then quietly just receded right back into the dark.
As we close out the case file on this explainer, I really want to leave you with a provocative thought. What else is the peaceful night sky hiding from us? The Tunguska firefall is this fascinating, completely solved scientific mystery, but it's also a major humbling reminder. Our cosmos is incredibly active, dynamic, and full of unseen kinetic energy just flying around out there. So the next time you look up at a quiet, starry night, remember that Siberian forest and definitely keep your scientific curiosity alive. Thanks so much for joining me. Keep asking those big questions, and I'll catch you next time.